The James Webb Space Telescope is wrecking everything. All of a sudden, we comprehend that we might have to reconsider all of the course books about the beginning of the universe. Michio Kaku has basically proclaimed that James Webb has tracked down what's close to the completion of the visible universe. So we ought to get further into this incredible sensation. The dynamic James Webb Telescope now illuminates the universe's cutoff. It examines a gigantic wilderness, a gymnasium of stars, galaxies, and confounding wonders. Imagine going into the undying storage facility where old, massive systems mumble the stories of the universe's beginning stage. Secure your seat straps as we begin this journey into space. We will uncover the insider realities of the universe's conclusive horizon. The James Webb Telescope has perceived 6 systems that exist a part of 1 billion years after the Big Bang. JWST is an electrifying advancement by NASA that got these cryptic problems of the universe. They bring us, and we answer their call. So go with us on this colossal discovery as the James Webb Telescope adjusts the stories of the universe. We must uncover what lies beyond our imagination. Stay tuned as we discuss the finish of the perceptible universe that limits existence. The journey for gigantic cognition has been a long one. Throughout its progression, humanity has looked toward the universe with interest. It has always viewed the boundless scopes of the universe. The theories behind space and the universe have perpetually eluded discussion, with various eras of experts and pioneers pursuing what's beyond our planet. The extreme excitement to understand quite far prodded them. Old societies, with no technology, used to gaze upward toward the sky. They would spin around great anecdotes about divinities and marvels. They used simple strategies to explore the night sky as a beautiful dance of stars, seeing the sky flabbergasted by the glorious patterns and potential ties between the Earth and what lies above. Modern improvements like the telescope improve humanity's cognition of the universe throughout time. The acclaimed Italian scientist Galileo Galilei glanced through the eyepiece and truly impacted our point of view on the universe. He saw Jupiter's moons, showing that celestial bodies could move around other than Earth. He traded the outdated geocentric system, which transformed science with subsequent advances. The Hubble Space Telescope began to scan the sky by taking stunning photos of far-off galaxies in their perspectives. Its lenses showed how stars form, how galaxies interact, and how black holes work. Each image expanded the yearning to uncover the universe's huge insider secrets. As new pretentious questions emerged, technological progress was made to answer them. Dark matter and energy rose out of bombastic lack of definition, revealing the universe's parts. The Big Bang's delayed repercussions began to appear in the immense foundation as technology advanced, unveiling new secrets. In this groundbreaking season of discovery, the James Webb Space Telescope illuminates the universe. It tests the mysterious universe using infrared beams. The brave journey for huge information inspires a renowned physicist and futurist Michio Kaku, who is a central figure in this journey. His unquenchable curiosity drives us to examine the obvious space. We can now see old systems, extreme horizons due to his thinking. This dumbfounding galactic excursion happens as technology propels. We understand that our goal goes beyond telescopes. The night sky paralyzes and moves us, empowering us to look up, not enduring the vulnerability. After a short time, we will be able to explore the depths of the dark. Kaku has highlighted the James Webb Telescope's examination of the neglected universe. This powerful instrument can rise above time, examine old universes, adjust limitless stories, and watch the universe advance with us. The James Webb Telescope uncovers the glorious. It sees infrared light as opposed to visible light, much like having special glasses that allow us to see further than normal. The JWST telescope is extraordinary. It is a masterpiece of engineering, a mix of innovation and a portrayal of human capacity. Its huge, enormous mirror has 18 hexagonal pieces. These mirror parts form a tremendous view that can see billions of light years into distant galaxies, stars, and nebulae. There is more to consider. JWST is a telescope and a time machine. It can detect light that has traveled through the universe for billions of years, allowing us to study the universe's beginnings. Light from ancient celestial bodies and infinite systems, found by the telescope, uncovers secrets from the far-off past. JWST is an interstellar globetrotter. It orbits the Sun at L2, the second Lagrange point, which gives a clear viewpoint of the universe without Earth's atmosphere. JWST works in harmony with Earth, maintaining alignment as it explores space. But what about the power of the Sun? A smart sun shield is used to protect JWST. Imagine a tennis court-sized solar cover with 5 layers that act as a giant umbrella. This barrier protects JWST from the sun's intense radiation, allowing it to cool to very low temperatures. This coolness is essential, as JWST's infrared sensors are sensitive enough to detect galactic signals even after its cooling. JWST's infrared capabilities mark a vital crossroads. It reveals secrets hidden by the astronomical climate, penetrating through dust and haze that block visible light, unveiling the extraordinary brilliance of faraway illuminating existences and material plates. Using infrared vision, JWST can examine young stars, cloud regions, and planetary atmospheres beyond our solar system. But how does this marvelous wonder happen? It's through private protection and global cooperation. NASA ESA and CSA work together on JWST. Designers, scientists, and visionaries persevered to create a telescope that is both a scientific instrument and a symbol of human solidarity. JWST's influence will be explored soon. We'll focus on its goal instruments and how they're expanding our grandiose understanding. This exceptional journey is driven by visionary scientist Michio Kaku. Together, we'll unravel the universe's secrets using infrared beams. The astounding discoveries of JWST have led to an unprecedented space mission. It will change how we understand the universe. Let's discuss the 3 shocking discoveries that have left scientists astounded. First, the telescope's observations have led to a reassessment of the Dark Ages. It's a period following the Big Bang when the universe was a field of darkness. JWST's fragile instruments have identified intriguing signs from this stage. They show star formation and intergalactic activity that appear larger than previously accepted. These discoveries have ignited a flood of scientific talk. They've changed how we understand the universe's early development and raised questions about long-held beliefs. In addition, JWST's capabilities extend beyond uncovering ancient systems. This power has allowed scientists to study extrasolar planets. It tracked the brightening of exoplanets as they pass their host stars and has provided captivating evidence of their atmospheres. This remarkable accomplishment opens new doors for assessing the potential for life. JWST has observed exoplanets and studied various planetary conditions. Thirdly, JWST's astonishing infrared capabilities let us examine the universe's origins. It revealed an abundance of galaxies that formed a couple 100 million years after the Big Bang. It offered the chance to look at galaxies in their developmental stages, going against previous hypotheses about the sequence of early galaxy formation. The visible universe and its limits have baffled scientists. Have you ever wondered about the vastness of our universe? Consider the universe as a massive theater where brilliant stars shine, galaxies twist, and mysteries hide. This vast scale is known as the observable universe, a domain that surpasses human understanding while still adhering to the laws of nature. The observable universe is like an innumerable window through which we can observe the entire cosmos. This is possible because instruments like telescopes allow us to analyze the universe. The ultimate speed limit is the speed of light, around 299,792,458 meters per second. So our perspective is limited to information disregarded by light over the years. Imagine the universe as an immense dark room. Your telescope acts as a spotlight, revealing only a small part of the area it illuminates. The darkness is vast. We can't understand what lies beyond the limits of our knowledge. According to scientists, the observable universe spans around 93 billion light years. It's like exploring a massive slice of reality where galaxies, stars, and celestial wonders reside. But if the universe is only 13.8 billion years old, how could something extend to 93 billion light years? It's a profound mystery. The expansion of the universe is like raisin bread baking in an oven. In this analogy, consider galaxies as raisins. As the dough expands, the raisins move farther apart. Since the Big Bang, this process has remained constant. Galaxies continue to drift further apart. So some are so far away that the light they emit hasn't even had the chance to reach us. It's like chasing a train that has already left. This cutoff, known as the particle horizon, marks the edge of the universe that can be observed. And what do we know? Rather than untangling the universe's expansion, it is speeding up. Dark energy is a mysterious force that pulls galaxies apart, increasing their energy. Eventually, some galaxies will be separated even further beyond the observable universe's edge. Beyond this boundary, we are left in awe. It's an unknown region hidden from our view, like staring into the dark distance without seeing what lies beyond. According to many scientists, universe clusters have yet to be discovered, unveiling ancient galaxies using data collected by JWST utilizing information assembled by the James Webb Space Telescope. Researchers are revealing old worlds that give hints about the early universe. As we peer further into the universe, we start to see further back in time than at any other time. The telescope's uncommon abilities permit us to explore the actual starting points of systems, stars, and, surprisingly, the arrangement of the actual universe. With each new disclosure, we inch nearer to grasping the significant secrets that lie past our scope. The James Webb Space Telescope has previously started uncovering these inestimable privileged insights, offering us an exceptional glance at the far-off past. Maybe we are taking a gander at a mirror that reflects our present, yet additionally the long-failed-to-remember past. As light from far-off stars and worlds contacts us following billions of long stretches of movement, it carries with it reverberations of a time that existed well before Earth and the planetary group. These disclosures hold the possibility to reshape how we might interpret the universe and our place inside it. The JWST's discoveries challenge existing models of the early universe and are as of now reworking the course readings. For instance, the revelation of worlds that framed only 200 or 300 million years after the enormous detonation challenges our past comprehension of vast development. These antiquated worlds seem to have shaped more rapidly and surprisingly effectively, inciting researchers to reevaluate the elements that drove the early development of the universe. The telescope's capacity to identify the slightest signs from the far-off past gives another window into this time of infinite history. One of the most captivating areas of study is the perception of exoplanets, planets that circle stars beyond our planetary group. The James Webb Space Telescope is extraordinarily prepared to concentrate on the environments of these far-off universes. By dissecting the light going through the climates of exoplanets, researchers can decide their peace, atmospheric conditions, and even quest for indications of livability. This ability opens additional opportunities in the quest for life past Earth. The JWST is additionally uncovering the point-by-point design of cosmic system bunches, which are among the biggest and most complex articles known to mankind. By concentrating on these groups, researchers can acquire bits of knowledge into the job dull matter and dim energy play in the development and advancement of systems. These perceptions might assist us with addressing key inquiries concerning the idea of the actual universe. For example, why it is extending and what powers are driving that development. Notwithstanding its logical commitments, the James Webb Space Telescope is an image of human accomplishment and worldwide collaboration. It is the consequence of many years of work by researchers, specialists, and visionaries from around the world, all unified in a typical journey for information. The cooperation between NASA, the European Space Organization, ESA, and the Canadian Space Office, CSA, addresses all that of what humankind can achieve when we meet up to seek after a common objective. As the JWST proceeds with its main goal, it will without a doubt reveal more mysteries of the universe. Each new revelation expands on the last, extending how we might interpret the universe and moving us to re-examine all that we assumed we knew. With the James Webb Space Telescope, we are wandering into the obscure, directed by the radiance of far-off stars and worlds. What's more, in doing as such, we are revealing the actual underpinnings of the actual universe, each disclosure in turn. The excursion is nowhere near finished. As the James Webb Space Telescope keeps on testing further into the universe, we can hardly comprehend what different disclosures lie ahead. What will we find out about the development of the principal stars? What insider facts will we uncover about the puzzling dim matter and dull energy that make up a large portion of the universe? Also, will we track down proof of life past Earth? These inquiries, and some more, are the main thrust behind the mission of the James Webb Space Telescope. Every revelation carries us nearer to figuring out the universe's starting points, its development, and its definitive destiny. As we keep on investigating the universe, we are helped to remember the immeasurability and intricacy of the universe, and the vast opportunities for disclosure that lie past our ongoing information.